Inshallah, we're going to solve questions related to Newton's second law. Now remember the steps to solve any problems on Newton's law. First, you have to write the given and check the units. Make sure the units are consistent. What do I mean by the unit are consistent? All the units either should be in SI units, SI unit, international system, which we use length, we use meter, kilogram for mass, and what else? Newton also for forces, temperature, Kelvin, etc. Or we will use the same units like Gaussian, if the units are in Gaussian, so all of them they have to be in Gaussian unit. Gaussian unit, centimeter, gram for mass, and second for time. We have to draw a free body diagram, all the forces that is acting on the system, determine the direction of motion. Why should we determine the direction of motion? Because the forces that are in the same direction as the acceleration should be positive, and forces opposite to the direction of motion, the negative. If I have forces in vertical and horizontal direction, we have also to specify that these forces in horizontal X direction or vertical Y direction, and then we apply Newton's whether first or second law. Let's start with the simple question. This is the easy one. I have a blue box. It is mass 5 kilogram. Okay, so from this information, we can get the weight down from the middle of the object. I have the weight or the gravitational force is mass times free fall acceleration. We will consider it 10. So this will give you 5 times 10 is 50 in Newton. And I have F applied to the right. What is the acceleration of the box? I don't have friction force, only applied force that will cause the object to move. So I have acceleration in this direction. Since I have acceleration, I'm going to apply Newton second law. F net should equal mass times acceleration. This is vector quantity, or F net summation of all the forces acting on the object should equal mass times acceleration. The only force that caused the object to accelerate is this applied force, which is equals to 100 in Newton. So I have 100 will equal mass is 5 times the acceleration. I need the acceleration, so divide both sides by 5. So acceleration will equal 100 divided by 5. It will give me 20 meter per second square. If I give you the same question, but this time I have a friction. So you have the same box and there is applied force to the right with 100 in Newton, and there is a friction. So I have Fk in the opposite direction. Always the opposite to the direction of acceleration or direction of motion is the acceleration. I need to find that if the coefficient of kinetic friction or dynamic friction between the box and sidewalk, so this is a mu k equals 0.5. There is no unit for the coefficient of friction because it's a ratio between normal force and friction. Find the acceleration. I need the acceleration. Continue the free body diagram. All the forces acting on the object. So from the middle here, I have the weight Fg, which equals 50 Newton, and I have a normal force up, and this is balanced with the weight. Since I have forces in X and Y directions, so I can make X and Y. So here I have X and Y. Okay. In Y direction, I have Fn, normal force, and that equals to Fg. Both of them, they equal 50 Newton. And forces in the direction of motion is positive. Opposite to the direction of motion is negative. So here I'm going to apply Newton's second law because here I have motion and I have acceleration. So all the forces acting on the object equals mass times acceleration. 100 to the right minus Fk to the left is negative will equal mass is 5 times the acceleration. We don't know the value of the acceleration, but we know Fk it's mu k times Fn. Mu k it's 0.5 and Fn is 50. 0.5 times 50, it will give me 25. Okay, so this will give me 25 in Newton. We're going to substitute here 100 minus 25 equals 5a. 100 minus 25 is 75. So 75 equals 5a. I need the acceleration, divide both sides by 5. So here the acceleration will be 75 divided by 5. It's 15 meters per second squared. The acceleration here is less than the first case because I have a friction. Okay, now next question. 120 kilogram pig in the elevator is on his way down. Okay. The acceleration downward is 5 meters per second. So the direction of the acceleration here is downward is 5 meters per second. So this is the direction of motion. What is the normal force on the pig? So I have to draw free body diagram. So from the middle here, I have the weight of the pig down, Fg, and this is mass times acceleration, 120 times 10, 1,200 Newton. And the surface will push the pig up with a force. This will equal the normal or the reactant force, Fn. Direction of motion, all the forces in the direction of motion is positive. Opposite to the direction of motion will be negative and the motion in y direction. So I'm going to apply Newton's second law, summation of forces equals mass times acceleration. The force is down, I have 1,200 minus the forces up is Fn will equal mass is 120 times the acceleration 5. Okay, so 1,200 minus Fn will equal 600. Take this to the other side and change the sign. So 600 minus 1,200 will give me minus 600. Multiply both sides by -1 or cancel the negative. So the normal force will equal 600 in Newton. 600 in Newton. Now here in this question is same as this one, but here the elevator is moving upward. So the direction of motion is upward. I have Fg down, which is 1,200 Newton, and I have Fn. In this case, Fn is positive, direction of motion, the same, the forces in the direction of motion is positive, opposite to the direction of motion is negative. So when we apply Newton's second law, it will be Fn minus 1,200 will equal mass times acceleration. Take this to the other side. So Fn will equal 600 plus 1,200, and this will give us 1,800 in Newton. See the difference? when the elevator moving up, when the elevator is moving down. Here I have the gravity is positive, Fn is negative, and the normal force is less than the normal force when the elevator is moving upward. When the elevator is moving upward, the normal force is higher. Okay. The other question, question number 4, I have forces acting on a sailboat are 390 Newton north and 180 Newton east. So first, this is the sailboat. I have 390 Newton north. Now remember, here north, south, east, west. So this is north, and then I have east. I'm going to draw it a little bit shorter. This will be 180 Newton east. I have a mass, M, 270 kilogram for the sailboat. What are the magnitude and the direction of the boat acceleration? The direction, it will be the same direction as the net force. So the net force, this is from where we start, where it ends. So this will be F net, and these forces, north and east, they're perpendicular. So first I have to find F net. F net will be square root, because they are perpendicular. We're going to use the Pythagoras theorem. 390 square plus 180 square, and this will give us 420 in Newton. Now the direction, if I take this angle, I measure the angle from east, so it will be north of east, because I measure the angle, this one, north of east. So theta will be tan inverse opposite to this angle is 390 divided by the adjacent 180. So 65 degree north of east, because I measure the angle from east. Okay. Here I have two masses. They're joined together by a string. What is the tension in the string? Here I have two objects, so I have to draw a free body diagram for each object. Let's start with the first one. The first one, I have the gravity down, which is 10 times 10, it will give me 100 Newton. And I have the tension force up, Ft. The small object, I have the gravity down, the weight, 5 times 10 is 50 in Newton, and I have Ft up. Second thing, after we draw free body diagram, I have to determine the direction of motion. In which direction will all the system move? It will move towards the higher or the larger or the massive object. So toward this direction, this will be the direction of acceleration. Forces in the direction of motion is positive. So all the forces that is moving in direction of motion will be positive. Let's start with the big object first. The big object or the big mass. The big mass. Big mass, and then we'll go to the small mass. The big mass, okay, we're going to apply Newton second law since we have acceleration. Summation of forces acting in this object will equal mass times acceleration. The forces in direction of motion is positive, so I have 100 is positive, minus opposite to the direction of acceleration is negative, so this one is negative, will equal 10 times the acceleration, and this is equation 1. Let's take now the small mass. We'll go to the small mass. Okay. Same thing in Newton for second law. The forces in the direction of motion, I have Ft is positive minus 50. So Ft minus 50 will equal mass 5 times acceleration, and this is equation number 2. I need to find the tension force. In the question, find the tension force. I can add these two equations together to find the acceleration, and then substitute in either one of them to find the tension force. So I'm going to add equation 1 and 2. So add equation 1 and 2. Let's rewrite the equation 1. Equation 1, I have 100 minus Ft equals 10A. Equation 2, I have Ft minus 50 equals 5A. When we add here, I have minus and minus, so this is the cancel each other out. 100 minus 50, it will give me 50, equals 10 plus 5, 15A. Divide both sides by 15. So the acceleration A will be 50 divided by 15, 3.3 meter per second square. Now I can substitute in any one of them to find, I can substitute in this equation, equation 2. So substitute in equation 2 to find the tension force. So here I have Ft minus 50 will equal 5 times 3.3. Take this to the other side and add. So Ft will be 50 plus 5 times 3.3, and this will give us, after we round it, it's 67 in Newton. Okay. Question number 6. I have two masses attached by a string as shown in the diagram. What is the acceleration of the blue box? Okay, I have to draw a free body diagram for each object. So here I have gravity down, or the weight, and a normal force because it touched the surface. Here I have tension force. For the red ball, I have Fg down, and I have tension force up. Where the object, the direction of motion, this will be the direction of motion. So start with the Newton first law to the ball. So in Newton first law, we'll start with the ball first. Okay. The weight of the ball, 5 times 10, it's 50 in Newton. The force in the direction of motion is positive. So this one is positive. This is opposite to the direction of motion is negative. So it will be 50 minus Ft will equal 5 times the acceleration. This is in Newton second law. Summation of forces equal mass times the acceleration. Now let's take the small box, the blue box now. Okay. The blue box, I have these forces, they're balanced and equal. Fn and Fg, they're balanced, and since we don't have a friction, we can ignore the normal force. We don't need it. We need it if we have a friction to calculate the friction force. So Ft, this is in direction of motion. Ft, this is the force that is responsible for accelerating the box. So Ft will equal mass of the box. Mass of the box is it's what the mass of the box? 5. 5 times acceleration. So I have two equations with two unknowns. I can substitute, take Ft and substitute it here to find the acceleration. Or we can add, either add to get rid of Ft or substitute with the value here of Ft to find the acceleration. So if I add them, if we add them, or we can substitute with the value of ft here. So it will be 50 minus 5a will equal 5a. Take this to the other side. 50 will equal 10a. Divide both sides by 10. Divided by 10. Divided by 10. I should get acceleration will equal 5 meters per second square. Let's solve another question. Here we have an aeroplane with a mass of 1.2 times 10 to the power 4 kilogram tows a glider with a mass of 0.6 times 10 to the power 4 kilogram. If the aeroplane propellers provide a net forward thrust of 3.6 times 10 to the power 4, what is the acceleration of the glider? So here I have an aeroplane. It has a mass of 1.2. This I'm going to call it M1. And I have a glider. It has a mass, so M2. So M1 and here M2. The applied force F applied equals 3.6 times 10 to the power 4 Newton. I need to find the acceleration. So Newton's second law, F net equals mass times acceleration. F net is the applied force, which is 3.6 times 10 to the power 4 equals mass. I have two masses. So I have M1 plus M2. Both of them, they were going to move with the same acceleration. Now I can find the acceleration. So the acceleration, A, divide both sides by M1 plus M2, so A will equal 3.6 times 10 to the power 4 divided by M1 is 1.2 plus 0.6, both of them times 10 to the power 4, because both of them times 10 to the power 4. I can cancel 10 to the power 4, and then we calculate this one. It should equal 2 meters per second square. Okay, question number 8. You have a sled traveling at a speed of 3 meters per second, slows to stop 4 meters from the point where its passenger rolled off. What is the magnitude of the horizontal net force that slows the 110 sled? Assume acceleration due to gravity is 10 meters. So there is a sled. Okay. Weight of the sled is 110. I need to find the value of this horizontal force acting on the sled. Before I apply Newton second law, I need to calculate the acceleration. The sled start with initial speed, so I have the initial speed is 3 meters per second, slow down and stop, so the final speed 0 because the sled stops. Distance, the sled moves, this distance if start from here, so delta x equals 4 meters. So from the equation of motion, I can find the acceleration. V final square equals V initial square plus 2a acceleration times delta x. V final is 0 square, V initial is 3 square plus 2 times the acceleration times 4. Take this one to the other side. So I will have minus 9 equals 2 times 4 is 8 times a. Divide both sides by 8. So divide by 8, divide by 8. The acceleration will equal minus 1.125 meter per second square. I need F net, and now I can apply Newton's second law, mass times acceleration. Mass is 11 times 1.125. Ignore the negative is just for direction. This will give us 12.4 in Newton. Now, the last question is similar to the question we just did. I will keep it for you as practice. You should get, I'm just going to give you the value. Acceleration, for the acceleration, you should get negative 3.92 meter per second square. And the coefficient of static friction, you should get 0.39, which is almost 0.4. I'll keep this one as a homework for you. You apply the same steps as this question. Use this formula to find the acceleration. And the applied force should equal the friction force. So if applied will equal F friction, if applied, which equal mass times acceleration, should equal friction force in mu s times Fn. So this one, F applied, should equal Fs. And from here, you'll find the coefficient of static friction should equal A divided by G. I'll keep it for you as a homework. That's it. We're done with the practice questions of Newton's